Hello, welcome to the Long Road Physics introductory video. Just a short presentation, about 10 or 15 minutes, when I'm going to tell you a little bit about the course and about the summer work that we're hoping you'll be able to do before you come to Long Road to study physics. So my name is David, I'm the course team leader for physics, and I'm just going to get up PowerPoint to share with you to talk through how this course runs and hopefully give you an idea of how to prepare yourself to do as well as you possibly can. So as I say, it's an introduction to physics and to the summer work. First of all, welcome. I'll be very much looking forward to seeing you in Long Road studying physics. It's a fantastic course. We've been doing it for a few years, and the students generally really enjoy the work that we cover on this course. It leads very well from your GCSE work, and the teachers who are teaching physics have all taught GCSE in schools over the years. So the first thing is the actual specification we use. It's the OCR Physics A specification from 2015. Do be a bit careful, there is an OCR Physics B specification, which is clearly different, but we choose the OCR Physics A, as I said, because it leads on really well from the work that you've done at GCSE. You can find brief details in the Long Road prospectus or on the website underneath the tab of courses. They're only brief because that's obviously just for the website. The specification document itself is something of about 75 pages, but it's useful to refer to that at times. This is a 2-year course. It's full A-level. It's a linear course, so you will be doing 3 exams at the end of the course in the May of your final year, and whatever marks you achieve in those exams will go towards the grade that you get finally awarded. There are practicals that need to be completed across the course, and that goes towards the practical endorsement, which is essentially just a tick. Yes, you have got the practical skills, you've demonstrated the practical skills. It doesn't contribute anything towards the final grade. So the modules we cover, essentially 4 modules. In year 1, we do forces and motion up to Christmas, and then after Christmas we do electrons, waves and photons. Same pattern in year 2. We do Newtonian world and astrophysics up to Christmas, and particles and medical physics after Christmas. So probably useful to know about the weekly structure for how we teach physics. You get the same tutor for both years, so there's no split teaching or change in teachers during your course. You get 3 lessons a week, 1.5 hours each. You'll generally get at least a practical a week, depends on what exactly we are covering. Some areas of the course have less practicals than others. You will achieve a good understanding of the work because we ask you to do prep work before each lesson. That's to prepare you for what you're about to cover. We ask you to complete problem sheets each week, which is essentially practicing applying the physics that you've covered in that week. And we also give you a homework each week, which again is past A-level questions based on the work that you've been learning during the week. So it's an assessment of whether or not you can actually apply the physics you've been learning in class and studying during the week to A-level questions. You can get help for any of this at any point because 2 lessons of the Long Road week are study plus sessions, so teachers are available for one-to-one help. You can come up to the physics lab and ask for whatever assistance you need in any aspect of the course. Important to point out, you are getting 3 lessons at 1.5 hours each, so that's 4.5 hours teaching each week, and we would expect that to be reflected equally with 4.5 hours of your own study, where you're building up and developing your skills and understanding of physics. Practical work, we, as I said, have an endorsement of practical work across the 2 years. So essentially in each year there's 6 set practicals during which we develop your skills and record that you've achieved those skills. There are other practicals that are not part of the set practicals, which obviously help you understand some of the physics that we're covering. Practical work you do in pairs. Some can take a long time, can take a full lesson, and you also get a Long Road workbook for your practicals to help you write them up and achieve the necessary notes and conclusions from the practical that we've done. During the year you'll have assessments, essentially formative assessments, so these are helping you develop your understanding would be homework, class tests and worksheets, or we might be doing a number of questions during the class on your whiteboards. But again, you'll have an idea of how well you're understanding things, and you can ask questions to develop your understanding in these activities. Summative assessment, so more exam-based. This is a grade you've got from answering the questions and the marks you've achieved. We call them key assessments, KAs, usually half-termly, so keeping a constant check on what you are able to remember and apply from the physics that we've covered in each half term in an exam condition. End of year 1 exams particularly important because of course those go towards predicted grades used in year 2 for your UCAS. There's quite a few bits of resources that we have got prepared for you. So you have a learning outcomes booklet. Obviously lessons address learning outcomes, and you'll be able to see them and tick them off and refer to them in your learning outcomes booklet, which also has some questions to help you with understanding what those mean. You have a prep booklet for every lesson. There'll be a prep, about 5 questions that you need to refer to, maybe research, but get answers to before the lesson. There are booklets of problem sheets. So again, on a particular topic, Young's modulus, for instance, there will be a set of questions. They will be starting reasonably easy, but going on to quite tricky towards the end to develop your understanding, and weekly homeworks. We have a Moodle virtual learning environment for the college, and there's a physics page on there, which also includes an electronic interactive textbook, which is a useful resource for your self-study. And as I said before, there's support in what we call Physics Study Plus, where you can come and find your physics teacher. We also run a therapy session after college as well. Therapy in a general word, come and find out what you need to, or get help with what you need to for your physics. Things we've done in the past outside the classroom, we regularly each year go to the A-level physics lectures run in the Cavendish laboratories, Cambridge University. We also go to their Particle Masterclass, that's particularly in year 2 for the particle physics. There are 3 or 4 days, companies coming in who then run activities called project days, where you go out and you work in teams of other students on particular activities that companies have set up. We had a team took part in the International Space Design competition. We hosted a school visit from Paris. We've also got every year an education engineering scheme, whereby we have a team of students from physics who have worked very closely over a couple of hours every week with mentors from ARM, essentially learning to do some programming of a microchip and using it to do whatever project they've decided they're going to embark on. So again, really good opportunities for you to look at the world of work and develop your skills. And TWI, that's the Welding Institute, have links with us. They've come in and taught some lessons in the past, and we've been out to visit their engineering facilities out on the Science Park. Here's a picture of the Space Design Challenge. Students deciding how they're going to develop this mining satellite that was the challenge for this year. These are the students from Paris who've come over with Vincent, the French physics teacher, who I've met a few years ago. We've had a link with him ever since. TWI, the engineering facility, lots of metal, obviously a welding institute. They're all about cutting and fixing pieces of metal, but to very, very precise and high standards. So that's very interesting for the students. This is a visit to CERN, which occurred in 2017. These students actually won the engineering education competition scheme. So that was quite useful. There's a project day at TTP, so this is the technology partnership. They were trying to design a way of a device to give surgeons a way of inserting fat to reconstruct faces, which was all very interesting. We've got the EE scheme here, so here's Richard from ARM with the students doing a bit of programming. This is the project that was completed not last year but the year before. They actually won the people's vote, so that was great. I'm really pleased with them. Designing a pair of goggles that you probably just can't see here, but essentially they were to help people who are hard of hearing realize from which direction a sound they'd heard had come from. Engineering workshop in Cambridge University, again part of the ARM project, trying to design a mini sort of greenhouse. Here's some cheerful looking students at a lecture, the masterclass at Cambridge University. And that leads me nicely on to the summer work. Well, the aim of this is to prepare you for a really good start to the course. So the content that I've picked for the summer work essentially links to the work in the first few weeks of the first module, which you might remember was forces and motion. It's basically got 3 parts. A few motion questions to remind you about velocity, acceleration, etc., from what you've done at GCSE. A bit of research and some summary to do about gravity and about satellites. And then I've put in some extension work trying to make it topical about Elon Musk and his satellites that you can actually look at in the night flying over above you. Essentially, my hope is that this will prepare you for the start, as I said, but also interest you. And I'd really like you to show me how good a piece of work you can produce. Here's a couple of shots of the outgoing year 2s, not all of them actually in that photo, but there's a bunch of them from my year 2 class in the physics lab, and there's Bledden with our Einstein statue, but essentially that's a little glimpse as to what it does look like in Long Road. So good to talk to you, looking forward to seeing you next year in physics, and if you've got any questions, that's my email address down at the bottom corner.